In these last couple of videos, I'm just going to do some examples relating what we've talked about with the types of cubic structures that we've gone through for solids and what kind of math is involved in determining certain qualities and how we use the properties like atoms per cell or edge length to determine various aspects of an atom, pretty much. And so there's some important things though that I want to highlight. Number one, you need to practice this. Okay. I will kind of guarantee you that over the next two videos, I'm gonna do two examples. And on your next assessment, I'm going to have one problem from one of these two examples, not the same exact example, but a similar type. And so I'm going to choose one of those to put on your next assessment or the assessment over this unit. So you need to practice. You need to know the relationship between radius and edge length. And each of these types of cubic um, um, templates that we talked about has that relationship here between edge length and radius. You need to know how many atoms are per unit cell. Again, that's just a memorizing thing. Review how to find volume of a cube. Right? If you've done some geometry, you might remember that volume is just equal to the length of the cube of one side raised to the third power. And for our cubic cells, that's just going to be the edge length. All right, so the length of the cube is what we're calling edge length for a cubic cell. Remember how to find density. Okay, density is mass over volume. And then I'm going to throw another conversion factor that I would just commit to memory. And that is 1 meter equals 10 to the 12th picometers. So picometers are very, 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 very small. And since we're dealing with literally atomic size, we're going to be measuring things on a very small scale. So 1 meter is equal to 10 to the 12 picometers. One other thing that you should get familiar with right away, because we're dealing with density, and a lot of times densities of solids are in terms of some mass unit over cubic centimeters, not necessarily units of volume for liquids like milliliters. We tend to use cubic centimeters for solids. I want to go through some quick math. We know that there's 100 centimeters in 1 meter. But if I have a cubic meter, how many centimeters is that? It's still not 100 because in order to make a cubic meter, I had to raise this to the third power, which means I'm raising this whole thing to the third power. So 1 cubic meter is 10 to the sixth cubic centimeters. And on that same note, what if I want to convert cubic meters to cubic picometers? Well, if I go back to this conversion factor here, if I want a cubic meter, I need to raise this to the power of 3 as well. And so 1 cubic meter is 10 to the 36th cubic picometers. So either commit those to memory or just know how to go from a non-cubed measurement to a cubed measurement. That's up to you how you want to do that, but it's probably just easiest to memorize that. So here's example number one. Calcium crystallizes in a face-centered cubic cell with an edge length of 558.8 picometers. Find the radius and density and I'm going to say in grams per cubic centimeter of calcium. All right, well, let's just kind of list how we're going to find these things. So how are we going to find the radius? Well, the only formula we know that has radius of a face-centered cube in it is the edge length equals the radius times the square root of 8. All right, well, we know the edge length. The problem gives it to us. So here's the edge length. I'm going to put that in there. And so let's rearrange this equation real quick to solve for the radius. And then I'll just plug in at 558.8 picometers over the square root of 8. Just as a heads up, that square root of 8, that's an exact number, so that has an infinite number of significant figures. It's not one sig fig, it's an exact number. So I do the math, throw that into the calculator, and that comes out to 197.6 picometers. So there's our radius. Pretty easy. We just plug it into a formula. Now the density is a little more complicated. So density equals, we know density is mass over volume. Okay. Now, how are we going to find mass? Because if we look at our problem, there is nothing there. There's no mass of a calcium cell. Is there anything about this fact that it's a face-centered cubic cell that might get us to the mass of one cell? So I want you to think about that for a second. To find the mass, we need to know how many atoms are in a face-centered cubic cell. Well, that's one of the traits that you should memorize. For face-centered cubic, we have 4 atoms per cell. And where do I go to look for the mass of an atom? Oh, go look at the periodic table. Okay, but remember that mass on the periodic table gives us grams per mole. All right, so let's kind of go almost all the way back to the beginning of the semester. The relationship between atoms and moles, do you remember? How many atoms are in a mole? Avogadro's number, 6.022 times 10 to the 23rd atoms, known as atoms cancel out. Now I can use molar mass. 1 mole of calcium has a molar mass of 40.078 grams. Just look at that at the periodic table. And so everything cancels out. Notice I'm in units of mass. And that's going to be a very, very small number. 2.66 times 10 to the negative 22 grams. All right, and that's what I'm going to plug in to the mass part. Now, how do I find volume? Remember, all I'm dealing with is just a simple cube. So I'm going to use the formula for a cube to find the volume. V equals the length of an edge cubed. Okay, well, I have an edge length already. And what I'm going to do first is put that into centimeters. Why do I want centimeters? Because my answer needs to be in cubic centimeters. Okay, so let's take our 558.8 picometers. Let's put that into centimeters. Well, I know that 1 meter is 10 to the 12th picometers. And then I know that 1 meter is 100 centimeters. So that's 5.588 times 10 to the negative 8 centimeters. Now I can put this in there. I mean, you could have put the picometers in there originally and then done a conversion, but however you want to do it. I'm just converting it now to centimeters because it'll get me right to cubic centimeters at the end of the day. So volume equals 5.588 times 10 to the negative 8 centimeters cubed. And that comes out to 1.745 times 10 to the negative 22nd cubic centimeters. Now, again, I want to highlight these are very, very small. numbers because we're literally dealing with 4 atoms. Okay, this is a very, very small cube. So now I have my volume, and I can plug that in there. So let's plug our 2 numbers in. So there's the mass, and here's my volume in cubic centimeters. And that comes out to 1.53, give or take some rounding, grams per cubic centimeter. And in fact, I encourage you to Google the density of calcium, and it's actually like really, really close to that. The only difference between what you might find in the literature and what you find here is probably some rounding errors. All right, so that is one type of problem that may show up on the assessment over this unit. In the next video, I'll go over the other type.